Seeing as it's winter right now, we're not racing, but we are still building. This is our T-bucket. We bought the chassis and the body about February this year. We are working on the engine right now, so I'm just going to quickly go over what we've got to start with, and then we'll move on to putting the pistons in the engine, building the engine. We're going to make a bit of a series out of that so you guys can watch how we build our engines, and then we'll come back to more body related stuff, putting everything together and making this a proper straight rod. So in terms of the front end stuff, we've pretty much got everything that we need. We just need to make all the mounts for the shocks and put the headlight mounts on. We're probably going to use the same headlights as we've got over here on our 1932 Ford, just because it's a lot easier to put the indicator and everything else just in one headlight. It makes it a lot cleaner. This is just a mock-up engine to see where everything goes. We have got our nice shiny new headers though, just to figure out where we're putting our steering arm and the steering linkages. This is just honestly just seeing where everything goes. We've also decided to put the brake cylinder down below the floor because there's no space on the firewall. So we're figuring out where the pedals go in here. It's going to be a bit cramped, but it will work. So with the body and chassis, we also got this rear axle. We've got no clue what it is, so we're going to replace it with a Ford 9-inch. And we do have a nice shiny new fuel tank, which is sort of a classic T-bucket fuel tank. It gives it style, and it looks really nice. Obviously there's also a lot of body work to do, but it's nothing we can't do and nothing we haven't done already. We're probably going to take this floor out, redo it, fiberglass everything in, make it strong because it will be quick, so we want it to be safe as well. But yeah, now on to the engine.
Sam has asked me to make a video of the build of a small block Chevy engine that we're doing. The project car is actually over there. At the moment it's got another engine in it that we're using to mock up. It's a mock-up engine. The car is a 27 T-bucket Model T Roadster. So the idea is to build a small block Chevy to go in there that's pretty quick on the street. Something that will certainly give electric cars a run for the money. That's what a bit of fun. So looking back at this, this engine's actually been well used as a fast street engine. It's got a scat crank in it, stroker motor. It was already bored 40 thou over. Unfortunately the block was quite badly scored, so what we've done in this build is we've taken it out another 20 thou, so it's now 4.060, 60 thou over bore. So it means we've had to have it bored and honed, and new pistons, and everything has been balanced because this engine's really got a rev. That's where your small blocks generate a lot of power. We've got torque built in by virtue of the stroke, and then if we rev it we get some good horsepower numbers. It'll be really lively in a lightweight car on the street. Unfortunately we had to balance the crank externally. I like to internally balance the crank, but it was so light already, it made sense really from a financial point of view to have an external harmonic balancer with some weight on it, and actually the flywheel, we put extra weight on that, so it's now balanced really finely so that it will rev. It's a 2-bolt main block, so we're going to be conservative about the horsepower that we put out of it. But what I'm going to try and do is go through some of the key points that we've found really work well when you're building a reliable fast street engine. Some of the little tricks of the trade. I'm not going to go through everything in detail, but like I said, just a few highlights for those who are doing it the first time to pick up, I hope, some good tips from us. We've already put number 1 piston in. So what we're going to do is go through the process of putting in number 2. Certain things that you might not realise are important. Obviously these pistons only go one way. If you think about it, these valve reliefs are there for a reason. your valves come in at an angle, 23 odd degrees. So you've got to realise where your reliefs are on that. I'm just going to swing the block over and tell you another thing that you need to know. The other thing that you need to know is your rods only go on one way. The main reason being is there's quite a chamfer on your crankshaft, and the other side of the rod butts up against the alternative connecting rod. So if you get them round the wrong way, your bearings will catch on there. One easy way of doing it really is to number the bearings when you take them out, so you always know they go in a particular orientation. That's a double check really, but I'll show you as we put the parts together why it's so important to get the pistons obviously the right way around and the rods. But novices can make mistakes, and it's always well worth talking about these things just in case there's any question. If you didn't number them properly, you will know by looking at the rods which way round they go. One of the first things you're going to do, you're going to have to make sure that everything is scrupulously clean. When the block comes back from the machine shop, even though it's going to be in the hot tank to try and clean off most of the muck, you will still get residual honing grit in the bores. So you've got to thoroughly clean it. I've already done this, so I'm just doing this to show you. I clean it with lacquer thinners. Some people will use water-based products. I steer well away from those because I like solvent that's going to evaporate. But you've really got to get it good and clean. Make sure that none of that muck is going to go back. If you think about it, it's like putting carborundum in your oil. It's just going to grind away at your bearings. So being clean in your assembly is really important. Once I've got that clean, I'm going to put ordinary engine oil. I'm using Kendall 2050 oil. Don't use synthetic oils to break an engine in. Steer well away from them. Everybody will tell you that. So you're either going to use your braking oil or a mineral based oil. I have a oil can specifically set aside for our engine building jobs. Just make sure that you put a nice light coating of oil all the way over the bore. That'll help your rings. Don't put any fancy engine assembly lubes on your rings, else they won't. That's for bearings. It won't bed the ring in. Now I've assembled everything ready to go together on the bench. So I've previously got my rings already gapped. So I'm now going to just backtrack a bit and show you how to do that very briefly. The key thing is to make sure that you've got the particular piston and ring manufacturer's information, because they will tell you the really important things. These rings are they're filed to fit. So they will tell you exactly the piston ring gap that you're looking for whatever application you're looking at. We're looking at naturally aspirated stuff here. So we've got the bore times 5 thou. So for every inch of bore, we're looking at 5 thou on the piston ring. So for 4.06 bore, we're looking at 20.3 thou on our ring gap. And I'll briefly show you how to do that. Right, so this is a brand new top ring. And if we try and put it in the bore, I'll use a squaring tool. You can see, well, I can't even get the squaring tool in because the ring has butted up. So we need to file this gap to get our 20 thou clearance. So we're going to go and use a proper ring gapping tool to do that. So the idea is we use this tool, tells you which direction to file it in. They're a bit trickier than you'd think. And you grind away. Now the idea is not to rush this, literally do a little bit at a time, and then you put it back in the bore and measure that clearance. You'll get a feel. I mean, I'm probably takes me 4 or 5 goes to get it right, and I'm measuring the gap as I go along until I get my desired 20 thou. So that's really important. The other thing that's really important is when you're finished, use a small stone and literally just take the burrs off. You don't need to chamfer it, But I tell you now, if you don't clean up these edges properly, when you go to put them in your piston, they will jam in the groove. So if you don't get things properly filed and cleared up, when you go to do your final assembly, as we're going to do, you'll wish you'd done it. So don't cut the corners, take your time, get a feel for it, and when you've finished, just take the burrs off the rings. And you'll do that for your top and your second ring, and the gaps are different for the top and the second ring on most of these pistons these days. The other thing to remember is the material's different, so they won't machine at the same rate as you file them. The second ring is probably much easier to actually file, so it will wear down much quicker as you set that gap. So there's little things like that you'll learn with experience. Right, so we're now ready to assemble the rod to the piston. As I mentioned, they only go round one way. This particular rod, number 2, is marked so that I always know that that's actually facing me on the crank throat. Now the other thing that you'll see, if you look at the rod, there's quite a generous chamfer on that side, and there's not on the other side. So you know that the chamfer goes on the same side as the large radius on the crank, and you know that the smaller chamfer goes when the two rods butt up together. And we also know that the piston goes with the eyebrows at the top. So bearing that in mind, we're now able to put the rod and the piston together. So we're going to assemble everything with lots of assembly lube. There are different types of assembly lube. Manufacturers have their own brand. The idea is that it's a really thick oil which won't just run off. So these engines are probably going to sit for quite a while before you actually run them. So it's important that you've got something that's going to hang on there maybe for months before you fire the engine and get the oil pressure running around in the engine. The other thing that we've got here, we're using full floating pins, and this means that rather than being pressed onto the connecting rod, they actually slide in and out. Now you can use, if you want, press-in rods. Most of the OEM rods, the original equipment manufacturer rods, are pressed in. You need a 30-ton press to press them out, but having said that, to press them back on, it's a real nightmare. You have to use a professional rod heater, and then you've got to be really quick when you do it. If you don't have enough heat in there for long enough, it will, if you only get it halfway in and then you try and press it in, you'll pick up material, and that means that your gudgeon pin has got the possibility of coming out when the engine gets hot. So I always prefer floating pins that are retained with a circlip, and that's what we're going to use today. So just double checking, eyebrows up, rod to the clearance. We can now just assemble these and put the circlips in. It's fairly straightforward. The nice thing about this is you can put your pistons together with these floating pins without having to go to a machine shop to get it done, and you can do it over and over again. So we're now going to just pop these circlips in. I won't go into much detail about that, but you'll see circlips have usually got a flat face, and they've got a face that's been stamped, which is slightly rounded. If you put the flat face on the outside, there's a better chance of them not popping out. If you're really worried about it, and in race applications, you can turn down a PTFE Teflon button that could go in there and try and locate them in the bore. You know, although they wear with time, they're a belt and braces approach to making sure that your circlips don't fly out, or use spiral locks or whatever other type of groove that you want. But for most racing applications, using a fully floating piston like this is a godsend. It speeds up the engine build, and of course the possibility when you're using pressed in pins for getting it wrong. Right, when you've got your circlips in, double check they're seated properly in the groove. If necessary, push the gudgeon pin either side, because you don't want them flying out. So we're okay. What we're now going to do is put the piston in a vise so we can hold it nice and securely while we install the piston rings. Just stop it from rocking and running around. Now it's important that we remember this is the forward facing towards the front of the engine. We're going to be using that reference because our piston manufacturer has told us that for the right bank of the engine, then, which is basically the piston pointing that way, we're going to orientate the rings in the various gaps where they've recommended. For instance, the top ring gap is at the bottom here, the second ring gap is here. We then put the oil ring spacer at the bottom, and then the rail rings go either side. All right. There's one other thing that we've got to remember while we're doing these pistons. We have an additional ring. This is required because we've got a stroker motor. Our gudgeon pin is actually breaking through the oil ring. So if we just put the rings in without a support bridge, the rings will be trying to go across to the gudgeon pin hole. So we've got this additional rail. It actually goes that way up. There's a dimple in it. So when that dimple is located in that groove, and I'll do that in a minute, it doesn't rotate. The other thing to remember is that the gap in this rail mustn't be anywhere near that, because it defeats the object if you've got that gap across here. So we'll just put that in by hand. Okay, so once we've got this rail assembled, you'll see this little dimple here. That's in that gap there, and it stops the ring from moving round. Because like I said, that is a bridge that prevents the oil control ring from breaking through the bottom of the piston there. So we've got to get this right. The orientation of these gaps is different from one side of the engine to the other. So we put the spacer, the oil control spacer in, and this gap is at the bottom of the piston, bottom of the bore. Then the rails are equispaced around the top. So we put the lower spacer in, give it a little bit more distance between the two. They usually just slide round just a bit more. That's it. And then you put the top rail in. These go in quite easily. The whole idea is not to scratch the pistons with the gaps. So we've got the spacer gap at the bottom and the rails equispaced around the top. We now need to install our pre-gapped second ring. The rings are handed because this has got a step underneath. So they've usually got a mark on the top, and that tells you the orientation. So the second ring, the gap is at the top. So the top is going to be there. Use a professional ring expander. You break these rings, you're in for another set. So we expand them, drop it down to the second and pop it in. No drama. We'll complete that with this top ring with the gap at the bottom of the piston there, so no need to show you that. But use the right tools. It's a lot easier, no broken nails and no damaged pistons. Before we go over to the engine to put this rod in, we're going to put the bearings in. I'm using Clevite 77 bearings. Really good, high quality bearing. It's really important. There's not an upper and a lower on these. They're both the same. Sometimes you find a bearing with a groove or a oil hole. For these big end bearings, there's nothing any different between the two. And you'll see as the bearing sits in there, you've got plenty of room here for that chamfer on the crank we were talking about. All we're going to do is put some of our bearing assembly lube on. Don't forget, this is the lifeline of your bearing, because this is going to stay on for those months it might stay in storage. So that is going to be there to stop this bearing wearing out when you first turn it over before the oil pressure runs up. But there's another discussion we'll have about how you get the oil pressure up later on. The other thing I want to do, double check, we've got our mineral based engine oil that's going on here. You know, this is the best stuff to use just to bed the engines in. I have used a product called Quick Set, I think it was called Quick or something. Anyway, it's basically a powder that you put in the bore. They say it's quickly seats the rings in, beds them in. To be honest with you, I prefer old school. I didn't like the way it felt. It worked. It worked on the Chrysler I built, but I would much rather prefer this. Right, that's ready to go in. We'll pop over to the engine now and go through what we're doing over there. Right, to install the piston in the block, I'm going to use this ring installation sleeve. If you've ever used one before, you'll know how useful they are. They're about 70 or 80 pounds, but they're worth every penny. They come specifically for the size of bore that you're going to use. You can use an expanding ring compressor, don't get me wrong, but you run a much greater risk of breaking a ring. They have a habit of not staying square, and you have to all fudge them to get them to work properly, especially with a big bore. So the idea with this is it will sit there and it's tapered, so you can drop the piston and con rod in and literally get it in one go without any trouble. The skirt will align it as we put it in. I've actually put some more oil on this sleeve. Got plenty of oil on there. The bore's already oiled up, so we're ready to drop it in. Now we want to get our hand under here to get hold of the connecting rod, just to support it while it goes in. Right, okay, that's all going in nice. There we go. Just make sure the con rod is free to move. It's not getting anywhere near the crank or the bearings. Just need to turn it around a little bit, I think. See how it goes. Now you'll feel this as it goes in. You get a feel for it. Don't forget you're compressing the rings as they go in. If you feel any resistance, you've got to stop and start again. Gently does it. There we are. Pistons in the bore. Now what we've got to do is just continue tapping it in and lining it up with the bearing. Nice. Now we will be checking that clearance between the two connecting rods later on when it's all assembled. That's critical. If you have it too tight, you won't get the oil flow that you need. Don't forget that oil is cooling your big end, so you want that clearance to be right. We'll check that when we finish the assembly, but for now we're going to turn the engine over and check the clearance on the cap. Right, I'm going to assemble the cap dry, because what I want to do is double check my clearances on the big end. Really, it doesn't matter how good you think you are with your micrometer and your bore gauge. It's really easy to get your clearances wrong when you measure them. The other thing is that your cap will distort as you torque it and install it. So I actually quite trust plastic gauge, which is this thin strip of plastic. What we're going to do is we're going to bolt the cap on. Don't forget the cap goes only one way with the rod, for the same reason we were discussing the chamfer on the large radius of the crank. What I'm going to do is I'm now going to put the recommended lubricant on the bolt threads. We're using ARP fasteners, which are an industry standard. The fasteners have to be torqued to a specific torque to get the right spec, and that torque is dependent upon you using molybdenum-based lubricant on the threads and the shoulder. Get that wrong and you will not get the rod stretch that you want, and that's absolutely critical to making sure when you bolt that con rod up that the bolts don't work loose and fly apart. So the torque spec is on the SCAT website, believe it or not. It is specific to the diameter of this bolt, which is 7/16 UNF. It's specific to the length of the bolt and the material. So it's actually specified as 8740 material. And they tell me that the torque spec on these bolts is 64 foot-pounds. Don't forget not only to put it on the threads, but to put it underneath the head of the bolt. You get friction on the head as well as on the threads. So we're going to repeat that for the other bolt and install it. Then we're going to get our torque wrenches ready. We're going to nip these bolts up. Make sure they're squarely seated. You can see the grease squeeze out between the joints. So I'm going to use 2 torque wrenches because we're looking at 64 foot-pounds, but I don't have a torque. To get the accuracy, I'm going to use a 50 foot-pound torque wrench to start off. We'll creep our way up. They say about 3 different torque settings. I'm just going to put 30 pound-feet on it. I can feel it as we nip it up. You might need to support your engine stand while you do this. So there we go. So I'm going to torque this up. I don't need to go through the process. I'm going to take it up to 50 pounds. Then I'll take it up on the other torque wrench to 60 and then 64. So we had that torqued at the recommended torque of 64. What we're going to do is just take it off again and see what our plastic gauge says as the clearance. Take the cap off, take the bearing out. There we go. Now that is what our plastic gauge has left us with. What you do is you use your measurement up against here, and we've got about 2 thou clearance. Now the race book says 2.5 thou. The Chevrolet owner's manual says it should be no more than 3.5 thou. So we're good to go. That gives us the confidence that our installed clearances are okay. So what I'm going to do now is I'll go and clean the plastic gauge off with some thinners, put my engine assembly lube on it, make sure I've got plenty of molybdenum paste on the threads again, bolt the cap on for the last time and torque it up in a number of steps up to 64 pound-feet, and we're good to go. What I'll do after that is then check the side clearance just to make sure that's okay. So we've put the cap back on the rod, big end, and torqued it up to the spec 64. We put more molly on and made sure we cleaned all the plastic gauge off and stuff like that. So as a final check, when we put our piston and rod assembly in, we just want to make sure the engine spins over okay. When you put in a stroker crank, you need to relieve all the block and everything. That's previously been done, but so I'm not worried about that. But it's just to make sure that nothing is binding, and so that's nice. And we'll do that on every piston and rod that we put in. The other clearance that I was talking about is this side clearance. Now, the standard rebuild book, Chevy book, will say anywhere from 8 to 14 thou. This clearance here is about 25 thou, and I'm not going to worry about that, and I'll tell you why. Because, like I said, we need to get that oil, once it's gone through the connecting rod, we need to get that away, because that oil flow is actually helping to cool these rods. If you look at an engine that's got too tight a clearance, you'll see that the main caps actually start going blue, and that's where you have these massive conrod failures and things leaving the block and stuff like that. So we can live with that, and in actual fact, to compensate for it, we're putting in a high volume oil pump as well. So I'm happy with that. I'd rather be that way than tight. So that's number 2 in. We're good to go. We're going to repeat the process for the rest of the cylinders, so we don't need to go through that with you, but we'll have a chat when we come to look at the cam and when we start installing the heads and other things like that.